Alright, Chapter 11, Discrete Mathematics. Alright, we have matrix, element, dimension, matrix, equal matrix, is scalar multiplication, identity, matrix inverse, matrix coefficient, matrix variable, matrix constraint, sequence, term of sequence, term of sequence, a series, arithmetic sequence, common difference, arithmetic sequence, geometric sequence, common ratio, geometric series. Alright, 10, 11, and 1, matrix. Goal, perform matrix addition, subtraction, scalar multiplication. Table show the number of the items during the first day of the class foundry. A matrix can help organize data such as a fundraiser. A matrix is a rectangular arrangement of the numbers horizontal and vertical columns. Each number is a matrix is called an element. The dimension of the matrix over the m rows and nth columns over the m times n reads m by n. Rows by columns. The matrix of the fundraiser data shown with the notice of the entries of the table shown with the corresponding elements of the matrix. Alright, so the matrix has 3 rows, 2 columns, so the dimension is 3 by 2, and third row, the second element is 5. 2 matrix, plural matrix are equal if the dimensions are the same, and the elements in corresponding position are equal. So basically we have and then matrix operation can add or subtract matrix only if they have the same dimensions. So to add subtract matrix, you can add, subtract the corresponding elements. They must have they only have the same dimensions. So, C is not possible to subtract matrix for the different dimensions. So a 2 by 2 row cannot do by 1 by 2. Scalar multiplication. Operation matrix real number, often called scalar. The multiply matrix by a scalar. Multiply each entry of the matrix by a scalar. This process is called scalar multiplication. Solving matrix equations. You can use this to write your matrix equation, solving an equation involving the matrices. So we've had 2x plus 2x1, 4x1. So we should write as 2x plus 4 equals 12. 2x8, 2x4 equals 8, x equals 4. Okay. Matrix operation. Order operation matrix expressions similar with that real number to multiplying one matrix by a scalar, adding the product and subtracting product with another matrix, performing the scalar multiplication first. The properties of the matrix are stated below. Let A, B, and C matrices with the same dimensions, and let the K be the scalar. So associate property with A plus B plus C, A plus B plus C is equal to A plus B plus C. Cumulative property A plus B is equal to B plus A. Distributed property of addition K times A plus B is equal to K times A plus K times B. Distributed property of subtraction K times A minus B is equal to K times A minus KB. Exercises. Yeah. Or 11-2, multiplying matrices. Multiply matrix goal. You will use multiple matrix multiplication example 4 to find cost of the equipment. The hockey teams multiply with the two matrices A and B with the number of columns A with the equal to the number of the rows B. Is equal to the number of the rows A and B. So otherwise the product is not defined. The dimensions of A are M and M, and the dimensions of B are N and P. Then dimensions of the product are A and B or M and P. So A is equal to M times X times B times X and M. Dimensions of A and B and N are equal. So A and B is equal to MX plus B. Matrix multiplication. Define the product with a two matrix, multiply the elements of each row of the first matrix by the elements of each column in the second matrix, then add the products as shown below. So we have A, B, C, D, elements A, B, C, D, minus elements E, F, G, H. So we'd have A times E times B times G, AE times BG times AF times BH, or C times E times C times G times C times F times H. Properties of matrix multiplication, let A and B and C matrix, associated property matrix A times B times C is equal to A times B times C. Left distributive A times B plus C is equal to A times B times plus A times C. Right distributive property A plus B times C is equal to AC plus BC. Labyrinth 3, solving linear system using inverse matrices. Finding inverse matrix using solving linear system. Recall the number 1 is a multiplication identity of the real number because 1A is equal to A1A for the matrix n-to-n index matrices. Matrices that have one of the main diagonals and zeros elsewhere. If A is in n times n, then I is the I is the n-to-n identity matrix. The identity matrix identity A is equal to A identity equal to A. So we have a 2 by 2 identity matrix is 1 0 0 1, or identity matrix 3 by 3 is 1 0 0 0 1 0 0 0 1. And the two n by n matrix inverse matrices of their products are both in order of the two n indexes. So the example of the matrix of the inverse each of the A and B or B A, and they are switched around. So they've changed position, and their identity is identity. They have the same identity because they were inversely switched. Finding inverse matrices. To find an inverse matrix, you can use a graphing calculator similar by the inverse matrix is A to the negative first. Writing a matrix equation, a system linear equation standard form can be written as a matrix AX plus B, AX equal to B. Matrix A is a coefficient matrix system, X is a matrix of variable, and B is a matrix of constants. So X would be a matrix of coefficients, X with variables, X and Y, matrix constants being B. Solving matrix equation AX equals B represents system linear equation. A is inverse linear system has exactly one solution. X is equal to A to the negative first over B. To find the solution of linear system graphing calculator, write the system matrix AX equals B. Enter matrix A in the graphing calculator. Enter matrix B in the graphing calculator. Multiply inverse matrix A plus matrix B. Solution AX equals B equals X with the A negative first equals times B. Alright, determinant Cramer's rule, evaluating the discriminants, Cramer's rule, solving linear, associated with each square of the n rows by n columns, and the real number is called the determinant. The determinant of the matrix is denoted as A, or the absolute value of A. Determinant of 2 by 2 matrix would be of determinant A, B, C, D is equal to A times D times C minus C times B. The determinant of 2 by 2 matrix is the difference of the products of the elements, the difference of the products of the elements of the diagonal. Cramer's rule, you can use the determinant to solve the equation. The method is called Cramer's rule. Use coefficient matrix for linear system. Let A be the coefficient of the linear system. Linear system AX plus BY is equal to E. CX plus DY is equal to F. Coefficients of matrix A, row 1 AB, row 2 CD. Determinant A is not equal to 0. The system is exactly one solution. The solution is X. The determinant A is equal to column EF, column 2 BD. Y is determinant AC, determinant EF. Notice how the determinant each numerator has a solution found with the Cramer's rule of the numerator of x replaced with the coefficient x with the first column of the coefficient matrix constant linear system. For the numerator of y, you replace the coefficient with y in the second column of the coefficient matrix constraint constant with the linear system. Alright, 11.4. Introduction to sequence and series. Goals. Use and write sequences and write. Use and write sequence series. Collection of objects listed in a sequence collection is ordered with the first item, second item, third item, and so on. Some of the familiar examples of object listed in days or the week of the month of the year. In algebra, you can think of the sequence function of the domain start with a constant integer with the domain is not specified on the list. If the domain starts with 1, the value of the range of the function is called with the term of the sequence. The domain of the relative position of each term, the range of the term of the sequence. The first term of the sequence, reads as sub 1. Next term it reads as sub 2, and so on. So the finite search is limited to the number of terms, and the infinite continues without stopping. So we have the domains first sequence 2, 4, 6, and that reads as 8. 2 sub 1, 4 sub 1, 2 sub 1, 4 sub 2, 6 sub 3, 4 sub 4. Infinite sequence of 2, 6, and 8. Write rules and sequence of the term and sequence may have the recognized pattern. If you may be able to write the rule of the nth term of the sequence, some common patterns are particular values added to each consecutive term of the sequence. Another is each term is multiplied by a constant, and each term is rated to a particular power. Graphing a sequence. You can graph a sequence letting a horizontal axis representing position numbers of the domain and vertical axis representing the term of the range. Finding the sum of the series of the term of the sequence if added to the resulting expression series, a series of finite, infinite, finite sequence 2, 4, 6, 8, 10, 2, 4, 6, 8 plus 10, finite sequence 2, 4, 6, 8, 2, 4, 6, 8, 10 plus to the nth. So some of the finite series we found adding the following. Sequence with many terms. For a sequence with many terms, adding the terms can be tedious. You can solve with a formula like given the sums of the terms of 3 special types of series. Some of the ends first. Some of the ends of first negative positive integers. Some of the squares of first nth positive integers. So we'd have nth integers and then sequence negative integers. And that was chapter 11, I think so. Part 11.15, the arithmetic and sequence series. And what are the rules of the arithmetic sequence to find some of the arithmetic sequences? The sequence below represents the number of cards in each of the first 5 rows, 3, 6, 9, 12, 15. For example, the arithmetic sequence and arithmetic sequence, the difference between consecutive terms is constant. Constant difference is called common difference, is noted as D. For example, the number of cards in each row of the house of cards has a common difference of 3. A to the sub base 2, A to the first base, arithmetic sub base 2 minus arithmetic base 1. Equals 6 minus 3, and then, yeah. Rules of the arithmetic sequence. Nth of the term of the sequence, the first A to the first, sub 1, A sub 1, common difference A of the denoted difference can be used in the following. A to the sub n is equal to A to the A1 plus n minus 1 to the denoted term. Arithmetic series, the expression formed with the adding terms of the arithmetic sequence called the arithmetic series. The sum of the first nth term of the arithmetic series is denoted by the s to the base of nth. Can be found using the following formula. Sum of the finite arithmetic series, sum of the first nth terms of the arithmetic series given in the following formula. The arithmetic series nth is nth to the a the first over the plus a to the nth over 2, where some of the first terms of the arithmetic series to the arithmetic series nth, meaning of the first and the nth terms multiplied by the number of terms. 1.5 exercises. Quiz 11, 6 geometric sequence and series. Write the rules geometric sequence, find sum of the geometric series. Diagram below shows snowflake curve each of the first 3 stages. Sequence 3, 12, 48, 192, 768. Represent with the number size of snowflake curve each of the first 5 stages. The example of the geometric sequence is the ratio. Any term of the previous term constant. The constant ratio, common ratio, is denoted as R. For example, sequence numbers of the sides of the snowflake curve and shown as a common ratio of 4. Rule of geometric sequence. The nth term of the geometric sequence is with the first term the ratio can be found using the following rule. The nth term of the geometric sequence is equal to the first term to the ratio of the number term minus 1. Geometric series with the expression formula denoting terms of the geometric system called geometric series. The sum of the first nth terms of the geometric series is known as a series to the nth. Series used on the nth term can be found by using the following formula. Sum of the nth term of the geometric sequence common to the ratio is not equal to 1 is given the following. The geometric series first noted nth series to the nth is equal to the first of the series equal to 1 over the ratio to the nth over 1 to the minus of the ratio. Exercise 1.6. 1.7. Infinite geometric series. Finding the sum of the infinite geometric series, you can find the partial sum of the Sn first nth term of the geometric by adding terms on the partial sum of approaching a certain value. Sum of the infinite series, the s to the nth approves the approaching 1 as the nth increase with the conservative of the r. This is s to the nth, and as the first term of the series 1.5, the ratio 1 to half. We'd have a increases half over the nth gets closer to 0, which is the sum of the infinite. Sum of the nth term gets closer to 1. Sum of the infinite geometric series is 1. Negative 1 is greater is less than the ratio, and the ratio is less than 1 is given in the following formula. Sum of the infinite geometric series. Sum of the infinite geometric series first for the first term common with the ratio is given where the ratio absolute value is less than 1. If the absolute value of the ratio is greater than or equal to 1, the series has no sum. Repeating decimals. To repeat decimals as a fraction, write the decimal sum and use the rule of sum of the infinite geometric series. Chapter 11, Summary and Review. Matrix, element, dimension, matrix, equal matrix, scalar, multiplication, identity, matrix, inverse, coefficient, matrix, variable, matrix, constant, sequence, terms of sequence, series, arithmetic sequence, common difference, arithmetic sequence, arithmetic series, geometric sequence, common ratio, geometric series. Chapter 12, Introduction to Trigonometry.